obtain exponential Fourier series from trigonometric Fourier series. Obtain exponential Fourier series from trigonometric Fourier series. Any periodic function x of t can be expressed as, therefore, x of t is a periodic function, can be represented as in terms of Fourier coefficients a naught sigma n is equal to 1 to infinity a cos n omega naught t plus sigma n is equal to 1 to infinity bn psi n omega naught t. That is equal to a naught sigma n is equal to 1 to infinity a cos omega naught t. In terms of your identity, e power j n omega naught t plus e power minus j n omega naught t by 2 plus sigma n is equal to 1 to infinity bn sin n omega naught t is e power j n omega naught t minus e power minus j n omega naught t by 2z. A naught plus sigma n is equal to 1 to infinity a n by 2 e power j n omega naught t plus split into 2 of sigma n is equal to 1 to infinity a n by 2 e power minus j n omega naught t plus sigma n is equal to 1 to infinity bn by 2j e power j n omega naught t minus sigma n is equal to 1 to infinity bn by 2j e power minus j n omega naught. Here numerator and denominator is multiplied with j. That is equal to a naught sigma n is equal to 1 to infinity a n by 2 e power j n omega naught t plus sigma n is equal to 1 to infinity a n by 2 e power minus j n omega naught t j into j square j into j square value is minus sigma n is equal to 1 to infinity j bn e power j n omega naught t. Here j into j square minus 1 minus into minus plus sigma n is equal to 1 to infinity j bn e power minus j n omega naught. That is equal to a naught sigma. Here common term is e power j n omega naught t. Here e power j n omega naught t. Sigma n is equal to 1 to infinity a n minus j bn by 2. Here 2 is there. E power j n omega naught t plus sigma n is equal to 1 to infinity a plus j bn by 2 e power minus j n omega. Let C naught is equal to A naught, Cn is equal to An minus j Bn by 2, and prove that C minus n is equal to An plus j Bn by 2, that is equal to Cn conjugate. We know that prove Cn value. Cn is equal to An minus j Bn by 2. An is 2 by T naught, small t naught plus capital T naught, x of t cos n omega naught t dt minus j 2 by T naught, small t naught plus capital T naught, x of t cos n omega naught t dt. Here not cos, here Bn is sin. That is equal to 1 by 2. 2 by T naught is bring outside. Integral T naught, small t naught plus capital T naught, x of t from cos n omega naught t minus j. 2 by T naught is bring out j sin n omega naught t. To cancel, therefore Cn is equal to 1 by T naught integral T naught small t naught plus capital T naught, x of t is equal to e power minus j n omega naught t. See the Cn. Cn is the exponential Fourier series coefficient. Very important. 1 by T naught, small t naught plus capital T naught, x of t e power minus j n omega naught t. This is the Cn. Here cos n omega naught t minus j sin omega naught t is the, according to Euler's identity, e power minus j n omega naught. Prove that C minus n Cn conjugate is equal to 1 by T naught integral T naught plus T naught x of t e power j n omega naught t dt is equal to an plus j bn by 2. An plus j bn by 2. We know that Cn is equal to 1 by T naught integral T naught plus T naught plus capital T naught x of t e power minus j n omega naught t. Here n is replaced with minus n. Here n is replaced with minus n. Therefore, C minus n is equal to 1 by T naught, small t naught plus capital T naught. X of t, e power n is replaced with minus n, omega naught t. That is equal to 1 by T naught integral T naught plus capital T naught x of t e power j n omega naught t dt. 1 by T naught integral T naught small t naught plus capital T naught x of t e power jx is equal to cos x plus j sin x. That is equal to cos n omega naught t plus j sin n omega naught t dt. 1 by T naught integral T naught plus T naught x of t cos n omega naught t dt plus integral T naught plus T naught small t naught plus capital T naught x of t. Here j term is bring out sin n omega naught t. Multiply numerator and denominator with 2. 1 by 2. 2 by T naught integral T naught plus T naught x of t cos n omega naught t dt plus 2 by t bring inside 2 by T naught j here j 2 by T naught small t naught plus capital T naught x of t sin n omega naught t dt. That is equal to 1 by 2. 2 by T naught integral over T naught of small t naught plus capital T naught x of t cos n omega naught t is an plus a n. Therefore, C minus n is equal to 1 by 2 an plus j. This is the another proof. Cn is equal to 1 by 2 an minus j. C minus 1 is also called as a Cn conjugate is Cn is equal to 1 by T naught integral T naught plus T naught x of t e power minus j n omega naught t dt conjugate. That is equal to 1 by T naught integral T naught plus T naught plus T naught. X of t conjugate is x of t is real, x of t conjugate is x of t e power minus j n omega naught t conjugate e power j n omega naught t. That is Cn conjugate is same as C minus n. C minus n, that is equal to 1 by 2 an plus j. Substitute these values in that expression. This one is a Cn, this one is a minus Cn. C minus n. Of t C naught sigma n is equal to 1 to infinity Cn e power Cn e power j n omega naught t plus an plus j t n by 2 is the C minus n e power minus j n omega naught t. E power minus j in omega naught t sigma n is equal to 1 to infinity C minus n e power this one is e power j into omega naught t, e power minus j, okay? C naught here, sigma n is equal to 1 to infinity Cn e power j in omega naught t. Here n is replaced with minus n. Is replaced with minus n means minus 1 to minus infinity. C of minus n is Cn. E power n is replaced with minus n. That is equal to j in omega naught. Here simply n is replaced with minus n. N is replaced with minus 1. The intervals are like that. Generally, the n value is 0, 1, 2 to infinity here, minus infinity, minus 1, minus 2, up to infinity. That is equal to C naught. C naught means that n is equal to 0. Sigma n is equal to 1 to infinity Cn e power j n omega naught t. N is equal to minus 1 to minus infinity Cn e power j. Combine these 0 interval. N is equal to minus 1 to infinity, n is equal to 1 to infinity. Therefore, the total n is equal to minus infinity to plus infinity Cn e power j n omega naught t. This is the exponential Fourier series expansion. It is obtained from the trigonometric Fourier series expansion. Here Cn is 1 by t naught integral t naught plus t naught x of t e power minus j n omega naught t